In this class, we'll learn about power. Now, the power is the rate of doing work. Which means the formula for power will be work done over time taken to do the work. In short, we would write power equal to work over time. So in other words, we can say power is work done in unit time. Maybe like 1 second. Now we know while doing work, we consume energy. So when work is done, an equal amount of energy is consumed. So we can also call power as energy consumed per unit time, or energy is the rate at which power is the rate at which energy is consumed. So power is also equal to energy consumed over time taken. We also saw that the power was also equal to work done over time taken. Another important point to remember is power is a scalar quantity. It has only magnitude and no direction. To go over it again, we said the power was a rate of doing work, or power is also the rate at which energy is consumed. So power can be said as energy over time or work over time. Now let's see what is the unit of power. The unit of power is watt. The SI unit of power is watt, and it is written as by a symbol capital W. Let's define 1 watt. So we'll now go ahead and define 1 watt. To define 1 watt, we go to the formula of power. So power is work over time. If work is equal to 1 joule and time equal to 1 second, then what will happen to power? Power will be equal to 1 over 1, and that is 1 watt. So how would you define 1 watt? Is the rate of doing 1 joule of work for 1 second. If 1 joule of work is done per second, the power is said to be 1 watt. So 1 watt is the power of an appliance which does 1 joule of work in 1 second. This is said to be 1 watt. Now 1 watt could also be defined as is the power of an appliance that consumes one joule of energy in 1 second. So you can have two definitions which means the same of 1 watt, 1 joule of work done for 1 second, or 1 watt can be 1 joule of energy consumed for 1 second, which means now, just to summarize, 1 watt equal to 1 joule over 1 second. Sometimes we use larger unit or bigger units of power, and that is 1 kilowatt, which is written as this 1 kilowatt. So 1 kilowatt equal to 1000 watts. You need to remember this, that 1 kilowatt equal to 1000 watts. But SI unit of power is watt, written as capital W. What is the power of a body which is doing work at a rate of 1 joule per second? So 1 joule per second will be 1 watt. So the power of such a body equal to 1 watt. A body does 1200 joules of work. So work done, which we write as W, is 1200 joules. In 2 minutes, time taken, which we usually put as T, is 2 minutes. Now remember, this is in minutes. We cannot work in minutes because the SI unit of time is seconds. So 2 into 60 second, which is 120 second. We need to calculate the power. Now the formula for power is work done over time taken. So here the work done is 1200 joule, time taken 120 second, and that would be 10 watt. So the power is 10 watt. A trolley is pushed along a road with a force of 400 newtons. So let me write that. Force 400 newton through a distance of 60 meter. So distance 60 meter in 1 minute. Time 1 minute. Now this 1 minute is not SI unit. We have to make seconds. 1 minute is 60 seconds. We have to calculate the power developed. Now we know power equal to work over time. But you must have noticed here that the work is not given to us. We need to find the work. So we know formula of work. Work is force into distance or displacement. The force here is 400 newtons and the distance moved is 60. So the work will be 24000 and the unit of work is joule. So now we go back here, we found the work is 24,000 over the time is 60. So the answer will be 400 watt is the power of the trolley. A boy weighing 40 kg, so mass of boy kg, carries a box weighing 20 kg, so mass of box 20 kg. To the top of a building 15-meter high, so this is the height, which we usually write as h, is 15 meter in 25 seconds. Time t 25 seconds. Calculate the power. Now we know power equal to work over time. Now in this case, the work done to lift an object, we've learnt it last time, and the work done to lift an object is mgh over time. Time we put as t, the work is mgh. So now let's put the values. The mass here, as the boy is lifting, he's got to lift his weight plus the box. So total mass is that of the boy plus the box, which is 40 plus 20 and 60 kg. So this is 60. The g they give is 10 meter per second. The height we saw is 15. He's lifting it to a height of 15. So this is the work done. Time we saw was 25 given to us. When you work this, you get 9,000 over 25, which is 360 watt is the power of this boy. So in this sum, the work was not directly given to you, but you know the formula for work was mgh, because while lifting an object, the work done formula is mgh. A man weighing 500 newtons, so his weight, remember weight is mg, is directly given 500 newton, carried a load of 100 newton. So this is the weight of the man, and now the weight of the load that he carries will also be mg, which is 100 newton. He climbs up a stairs 4 meters high, so height h is 4 meter in 5 seconds. So time 5 seconds. What is the power? Once again, power is work over time. Now in this case, the work is work of lifting, so the work is mgh over time t. Now it's very important to note here, the m into g multiplication is already given to us, that is 600. The total mg is 600 newtons. 500 plus 100. We don't have to multiply the g because newtons means it is mg. So mg, for mg I'm going to write 600. Then the height we know is 4 meter. The time is 5 seconds. So this works as 2400 over 5, which is equal to 480 watt. So the power equal to 480 watt. The important point to note here is when we are doing work in this, although work was mgh, but because they gave us a newton, mg was already given to us. All we had to do is multiply by h. How much of electrical energy? So we have to know energy is our question. Does 100 watt bulb, so power is given to us, is 100 watt, consumes in 1 second. Time 1 second. So we use the formula for power. Power in this case will do energy over time, because the energy is given to us. So power we know is 100. Here they've given the power is 100. Energy we need to find out. Time is given as to as 1. So the energy consumed equal to 100 into 1. And you know the SI unit of energy is joule. So 100 joule is the energy consumed in 1 second. In the second part of the sum, they want the energy consumed in 1 minute. So the formula is the same. So we have energy we need to find, question mark. Power is given as 100 watt and the time is 1 minute. Now 1 minute is 60 seconds. So power equal to energy over time. Now put your values. Power is 100, which they have given. Energy we need to find out, and the time is 60. So energy equal to 100 into 60, and that would be 6,000 joule is the energy consumed in 1 minute. The power output of an engine is 3 kilowatt. So power equal to 3 kilowatt. Now 3 kilowatt is not SI unit. We've got to make it SI. We have to make it into watt. So it is 3 into 1000. So which is 3000 watt. This is the first step. It has to be an SI unit. How much work does the engine do in 20 seconds? So we need to calculate work is the question, and the time is 20 seconds. So power equal to work over time. Now the power is already given to us as 3000. The work is to be calculated and the time is given 20. So work will be equal to 3000 into 20, that is 60,000 joule. And what if we were to convert it into kilojoules? So 6,000 joules, 60,000 joules. To make kilojoules would be 60,000 over 1000, and that would be kilojoules. $60 kilojoule. And an electric heater uses 600 kilojoule. So energy consumed (600 kilojoule). Now we cannot work in kilojoule. We have to make joule. So it will be 600 into 1000. So there will be 600,000 joules. In 5 minutes. So time 5 minutes. Now 5 minutes, minutes is not SI unit, change into seconds. So 5 into 60, which is 300 second. And we have to know the power rating. We have to calculate the power. So power equal to energy over time. So energy we saw was 6 lakh over time 300. Then we cancel this out, and the power became 6000 watt. 6000 over 3, and that would be 2000 watt. 2000 watt is 2 kilowatt. So the power is 2 kilowatt. You can leave it at 2000 watts too. A body does 20 joules of work in 5 seconds. So work done 20 joules in 5 seconds. Time taken 5 seconds. So we know the formula for power: work done over time taken. Power is a rate of doing work. So work is 20 joules, time taken is 5 seconds. So power is 4 watt. Unit of power is watt. What is the power of a pump? So power is a question which takes 10 seconds, time 10 seconds, to lift 100 kg of water. So mass of water 100 kg to a water tank situated at 200 meters. So height 20 meter, not 200, 20 meter. We need to find the power. But to find the power, we need to know the work done. So in this case, the work done in lifting any object is mgh. So m, we know the mass is here 100 kg, the g is given to us 10, and the height through which this water is lifted is 20. So work done equal to 2 so many joules. Now we go ahead and find the power. Power equal to work over time. So work is 20,000 joule over time, we saw is 10 seconds. So power will be 2000 watts. The power of this pump is 2000 watts. We cancel this out here. An electric bulb consumes 7.2 kilojoules. So that is energy. 7.2 kilojoule. Kilojoule, to make it into joule, into 1000. This will be so many joules. In 2 minutes. So time 2 minutes. Make it into SI unit, 2 into 60, 120 seconds. We need to find the power. Formula for power, here in this case, is energy over time. It could be work over time if work is given, or energy over time if energy is given. So energy over time. So energy here is 7.2 into 1000 joules over time, 120 joules. So to remove this decimal of 7.2 into 1000, what I do, I put a 10 here to remove the decimal, and I put 120. So this cancels out, this cancels out, and the answer here works out as 60 watt. This is 6 here, 60 watts. So the power of the electric bulb equal to 60 watt.